And then we want to take the derivative of the inside. So we're going to multiply 7, since 7x's derivative is 7. So for an easy shortcut, we can go ahead and write 7x. 7 divided by the square root of 1 minus 49x squared. And that's what we do with inverse sine. Let's go ahead and do another problem here. Y equals ln of x to the 4th power. Now there are two ways you can do this. If we use the chain rule, we can rewrite this as y prime equals. Now let's say we got ln is going to be 1 over x to the 4th, or times the derivative of the inside, which is going to be 4x cubed. And this is going to be the same as 4 divided by x. Now the second way I mentioned is that you can use the properties of logarithms and move the 4 forward. Now this is also 4 times ln x. And then you can use the constant multiple rule, and then easy as pie, you get 4 divided by x. Both ways give the same results. Now let's go ahead and find the derivative of, let's say you got the ln of the cosine inverse, ln of the cosine inverse of, you got 7x. I know I'm obsessed with 7x, but I'm just giving an example. Y prime is going to be 1 divided by the inside, that's cosine inverse of 7x, times we got negative 1 divided by the square root of 1 minus, now this is going to be 7 minus x whole squared, so that's going to be 49x squared, times 7. And we're just going to leave it like this because we can't simplify the denominator. And now we can also use logarithmic differentiation on other functions as well. So on other functions too. So let's say you're dealing with these complicated square root functions here. So that's going to be, ln of, let's say we got y equals, we got square root of x squared minus 5. We got 2x divided by, let's say we got 9x. Now, if you were to find the derivative without doing logarithms, you're going to have to use the quotient rule, product rule, and chain rule. But you can do this by taking the logarithm on both sides. Ln. If we use ln here, so now this is going to be where we use implicit differentiation, and this is where the last video is very useful. If you haven't watched the last video, be sure to watch it right now. Alright, so now we leave ln of y. If we were to differentiate it, we got 1 over y. 1 over y equals, now we're going to go ahead and simplify this right-hand side, because this is very complicated here. So this is ln of 2x plus, so this is plus the ln of x squared plus a negative 5 minus the ln of 9x. And if you notice here, this is also the dy dx. And then the derivative here will be this whole thing times y. Or that will be equivalent to 2x times square root of x squared minus 5 divided by 9x. So let's talk about another case where you would use logarithmic differentiation. So let's say you have the function y equals x to the power of x. Now you have both the base and the exponent as variables, but we have no rule saying that it's not possible to differentiate this type, but we can use logarithmic differentiation. So typically, whenever you do logarithmic differentiation, you can take log to any base, but ln is typically the easiest. So this will leave the ln of y equals the ln of x to the power of x. And now what we want to do before taking the derivative on the right side is that you want to move the x forward. So that will be ln y equals x times the ln of x. And then what you want to do is take the derivative. So this will be dy dx times 1 divided by y equals, now here we got x times the ln of x. We're going to use product rule. So we got x times 1 divided by x plus, now this is going to be x derivative is 1. So we're just going to put ln of x here. And this will be now dy dx. Should be equivalent to, if we multiply y on both sides, y times 1 plus ln x. Now this is in terms of two variables. Now we already have information that y is x to the power of x. So we can substitute that in for y. And this will be the final answer. See, even when there is no ln or log, in some cases you definitely need to use logarithmic differentiation. And that is all for the differentiation concepts. Now we're going to move on to integration concepts here. Now what exactly is integration?